In this series, we will give famous theorems from high school geometry. These theorems are useful to understand the other theorems, and it will make you a perfect problem solver for the geometry. So we will begin by Heron formula. Heron formula. So what is Heron formula? Heron formula gives a method to obtain the area of the triangle by using the only sides and the semi-perimeter. So let ABC a triangle and A, B and C A, B and C are measures of the sides of the triangle and S is the semi-perimeter of the triangle. So then the area of this triangle, let's say ABC, is this one. Area ABC equals square root. So S times S minus A, S minus B, S minus C. Okay, you need the semi-perimeter and the area. Of course, we know the area of the any triangle is to multiply sides and the altitude. But this one gives another method to obtain the area of the triangle. So let's give a proof for this formula. So first let me draw the graph. So this is our triangle. So this one is A, this is B, and this one is C. Also, let's draw the circle, inner circle. Okay, let's see this side. Okay, let's okay, is okay. So this side. Okay, so this is the tangent point and this one. So let's say this is the line connecting this point to the center. So let's say this is the center. Okay, now let's travel this one and this one. Also we have this radius. Okay, now we give a name for these points. So this one D, this one is E, and this one is F. Now, okay, let me write this C like this one. So now I draw a line segment here, and let's say this is K, this point, and DA is equal to CK. So I can draw this length. Now let me choose a point here, point P. Okay, let me. Okay, exactly here. So let me draw this one. This point is P, and this is the right angle. So from here to here, I draw the orthogonal line segment. So this is the orthogonal here. And also let me connect these 2 points. So this is my P. Of course, there are some other proof for the Heron formula, but I will give the geometric proof. So first of all, if you look at this DOA angle, you see we have the right angle here because this is the tangent one. So this is the right angle. So this, because this radius D, so let me say right, OD equals OE. So same thing is correct for the OF. Okay. So also we know the DA is equal to AE. So that's why this is right triangle, and we have a common side here. So also which one? AO is common. So we conclude this one. These two triangle DAO and AAO, these are congruent to each other. So because these congruent, we have this and this one. These are the same. So that's why DOA angle and okay, let me write in this form. AOA is EOA is same angle. So similarly we have other one. So let's say this and this one, and so let me write the other parts. So similarly we have DOB equals BOF. Also we have FOC EOC. Okay. Also, if you look at these BOP and BCP, they have common hypotenuse BP. So that's why we can say BOP and BCP are inscribed angles in a circle whose diameter is BP. So this tells us this quadrilateral BOCP is cyclic. And we know that in this case, the angle BPC is supplementary to BOC. Okay. Now, by using this information here, so now we see this is equals, these are equals, and these are equals. So we can write from this information angle BOF plus let's say M BOF measurement M FOC and this angle and M DOA, and because this is the half of the complete angle, it will be 180 degrees. So what this tells us? This tells DOA angle is supplementary to BOC. So this angle BOF FOC, so it becomes BOC. BOC. Now look at this one. Now DOA, so this angle is supplementary to this angle. Also this BPC also is supplementary to this angle. So we conclude that this DOA equals BPC. Now we have two things here. One, we have right angle, these two triangle. Also we have this angle, they are equals to each other. So by angle-angle theorem, this DOA, so this DOA triangle is similar to the BPC triangle. So from this we can write BC over, so this angle equals to DOA, so DA over DA equals PC over DO. Okay, so let's say this one is 1. Also, if you look at this one, okay, let me use the red one. So this angle and this angle are same. So it says this FO, let's say here G, this point as a G. So FOG equals similar to the PGC. So FOC triangle is similar to the FOG. This one should be G. Is similar to the PGC. So this we can use similar triangles. So it means GC over FG. GC over FG equals PC, this one, PC over OF. So let's say these two. Now we know this OD equals OF. Why? Because they are both radius. So it says BC over AD equals GC over PG. So let's say these three. Also, in the beginning, we suppose that this CK equals DA. So from here, BC over CK equals GC over PG. Let's say these four. So from here, we can write this one as BC plus CK over CK equals GC plus GP over GP. And from this, we write BK, because BC plus CK, BK over CK equals, so this one, okay, I write this one is, okay, so this one is GF, right? So from 2, I forget to write FG, this is FG, this one, I just write, when I write this one, I didn't carry properly, so this should be FG, so this one is FG, this one, so the bottom also is FG. So from here, you see in this case we have FG plus GC over FG. So here we have BK times GF equals FC times C times CK. Now, if you multiply, let's say this one is, let's say 5. If we multiply this 5 with BK, we have this one, BK square times GF equals BK times FC times CK. So let's say this is 6. Also, if you look at this one, this OF is altitude, so this one. So from this we have, in this case, OF square will be BF times FC. So also we have this one, OF square equals BF times FG. So this one is 7. Okay, now we can start to calculate the area. So first let me copy this graphic. Okay, let me remove this one. So now the area of this triangle ABC can be written as A area AOB plus area BOC plus area COA. Also here OF, OE, OD are all altitude for this triangle. So we can write in this form. So this area will be 1/2 OD times AB plus, so the second one, OF 1/2 again, OF times BC plus OE times 1/2 again, OE times AC. So we know OD, OF and OE are radius, so they are all same. So area ABC triangle equals, let's say, 1/2 AB BC AC times OF. So you see this part is S, this part the perimeter. So we have this one. So this one is not, so perimeter, so this one is perimeter there. So all together is S. So that's why we have this one, OF times this S. Okay, now if you look at this part, because this is a tangent to this circle, AD equals AE, BD equals BF, and CF equals CA. So it means you have this one, BF, okay, let me put number here, 8. This one is 8. So we have this now, BF plus FC plus AD is S. But we know the AD is equals to CK. So that's why BF plus FC plus CK becomes S. So it means you have this one. BK equals S. So let's say this 9. So this BK, so here we have K. So this BK becomes the semi-perimeter. So because of this, using this 9 in 8, we can write this area again, ABC triangle equals OF times BK. If you take the square, then you have ABC square equals OF square times BK square. Okay, let me look at this OF square. So we can write the OF square BF times FG. So we have BF times FG BK square. Now look at this one from the 6. BK square times GF. So I can write this one this side. So BK square GF. So this part I can write BF BK square FG. So this BF remains. So here we have this one. Okay. So area becomes area ABC becomes square root BK times CK times BF times so remain part FC. Now we already know the BK is semi-perimeter. So we have this one. So here we have S. Now look at this CK. CK is this part, and we know the CK is AD. So to find the CK, we need to subtract this BC, which is A. So that's why this one becomes S minus A. How about BF? If you look at BF, BF is this one. BF is this one. So you need to subtract the FK from the semi-perimeter. So FK becomes this one. ECAE, because AD equals CK, but also AD equals AE. So we have S minus P. So this part S minus P. And last part FC. If you look at this FC, you need to subtract the BF and CK from the semi-perimeter. So you see this one BF is equal to BD, CK equals to AD, so it means S minus C. So this part S minus C. So this completes the proof, and you see we used many properties from the geometry to complete this proof. As I said before, this is the geometric proof. Of course, there are some other proofs by using the trigonometry, but this one is more geometrically method for this formula.